if you have like a representation of some entity, you have some slow changing stuff, which is like typically IDs and some properties. And then you have some faster changing stuff, which is like a method. A person, you get a new context that the person has to be able to do this also, or that also. So you start adding methods because in another context that person has to be able to do this also. So you add a method. It's just one method. And then you start, it's exploding, right? So you've probably all tried this scenario that some class is just getting bigger and bigger, and then you might split it up. So you have some subtypes maybe, because you want to make it more like manageable, and you might even subtype even more, and you get into all these design patterns where you have like different hierarchies and stuff. Then you could also make a service where you have the slope, where you basically only have properties in some representation, like a case class with only the properties of the domain entity. And then you consume that in a service that does things, for instance, with the person. So you could have a person service where you have all the methods for a person. Or you could have specialized events or commands in an event sourcing system, which is like do this with create new person or create customer or whatever that consumes a person entity, right? So that entity, you might have got that with Hibernate and object relation model. So you define that a person has to be populated with this kind of data from the database according to this definition of the connection between the database and the domain representation, which is the environment. But it's pretty tedious. So if we generalize the consumer, you could say that you have an entity consumer. And it could be any kind, it could be a service and event source commands, like ad hoc classes, whatever, that consumes some person or something. Then you could even see that the person, the properties of the person having different cases of change, because, for instance, the ID of a person is probably very seldom or never going to change, right? Whereas some status of a customer is going to change often, more often. So how do you deal with the different speeds of change? You might even start to subclass even just the properties that are consumed by some entity consumer. I mean, entity consumer is just the name I give it. It could be just a general name for different kinds of doing it. So what I'm suggesting is that if you look at the properties of a person, you might have some properties which is like very long, but as we saw, we had like a side cat, which had nothing to do with the person. So even the properties of some entity might start polluting an entity class. So that's why I suggest that we use molecular entities where you have different variations of persons. So you might combine different, you have different kinds of persons in different situations, in different contexts over there. So if a user logs in, you might need the person's name, email, and password. And if it's a manager, you might need the person's clearance level. Or if it's a manager who has to like do something, manage some employees, it's other attributes that are related to that person. So it gives flexibility to domain modeling wise to have the ability to combine like non-intrinsic properties of entities. Are you following me? So, and then you can have like entity consumers that are very specific to specific processes. So you don't have one big box for anything that the person does. You have different processes that consumes different kinds of persons. So instead of having those molecules in a layer by itself, we might take them into those ones, because the molecules are so easy to create. So why not just create them inside here, right? because you're using the domain language. So we might not need domain classes at all. So why take the data out of the database, put it into a person domain class, just to take it out again inside the entity consumer? You follow me? So in some ways, I think that domain classes often just have the function of getters and setters. You're just populating with data and then you're just taking it out. It's a little bit stupid in some ways if you don't do anything intelligent with that data. And the intelligent stuff is going inside the entity consumers. That's where the processes are happening. That's where the business value is. It's not in the properties. It's how the properties are dealt with. So, if we imagine like a password change, we could imagine that instead of imagine that we get an object, a person object that has been populated with some data about that person, getting that in, passed into to some process of changing the password. We just pass the entity ID. That's the core of that entity. This is the super basic core. It could be the social security number or the personnummer in Sweden or whatever. But from that ID, we could create the person within here. Why create it out here and then pass it in? We might as well create it in here and then do what we need. So schematic, like generically, we could say like we get the entity ID, then we get the current user data that we need in this process. I think you have all tried to make a class or a query to the database, like give me some persons, or give me the person with this ID, and then you need some data, and then in another process you also need a person. Then you call the same function, but then you also need the address. So you add the address to the query, but you don't need the address in the first, right? So your query starts to grow, and then you get a lot of data that you don't need in specific cases. Or you do the cumbersome job of like creating individual queries for each process, right? Because it's not so smart to get like way too much data with the address and all kinds of other shit that you don't need. Because this process only needs the email and password, for instance. So you might make a molecule where you have the domain names, user, email, and password, and then you get those two values. And those are the two values that you do to check the stuff. Like, is it a valid password, and does this person have clearance to be authorized or whatever? And then you save it. You encrypt the password and user ID, password, save the encrypted new password. So since you're using the domain names directly to both get the data and save the data, I think it makes sense to bring it into the process where it's like, so you get exactly the data you need for that process, and it's explicit and typed. I think it's interesting to explore, at least.
Do you think the reason for that is that you have every piece of data, so like flattened out, and have a key for that piece of data, whereas in the conventional database you have everything grouped and a key, so it's kind of impossible to just get one of them and then rearrange and stuff.
Exactly.
Yeah, so.
I think so. I think the normal tables are very rigid.
Yeah.
They're stiff. Even document stores, where you define a document with certain fields of data, but when you have the other process, you have to make a new document structure. And that's too tedious, so you just reuse the old one, right? Because it's almost the same data, you just add the one extra little address. It's okay, it's just an address, right? So your data is not matching what you actually need, because it's too tedious to do it. So I think this is more clean.
Could you, in a way, say that you're dynamically creating your domain class there?
Exactly.
Because it looks like you're using a domain class, but
Exactly.
actually you're talking to the data in the database.
Exactly.
Yeah.
So your domain language is coming into your process, so you can get the slow changing things that you have something called email. you have an attribute called email. That's a very slow changing thing. It's like the periodic system of atoms. It's very seldom changes, right? So, but the molecules, they change more or less often, but the processes with the enzymes and all things, that changes all the time, right? So, if you look at those things, the different pace of change, I think it makes sense to bring in the domain language of the slow pace things into the fast-paced processes like this, because you can combine them flexibly.
I guess this requires you to have a pretty good cache for the. You rely on the cache here, because if you have use cases where you do things with this user, for example,
yeah,
you have use case and you do this all over the place in different services.
Yeah,
you would load the same user data multiple times.
Yeah, but the thing is that you're not going over a network, which is an expensive connection to a big database server anywhere. It's all in memory. So once it's cached in the peer memory in your application process, it's there. So the facts are there.
But do you cache? Can you specify what attributes you want to cache for a specific?
No, but I think the atomic peers are extremely intelligent in caching, because it's all immutable order, and it has such a simple form. So you have these. They both have the.
But let's say you have 10 attributes on user, and you use them in different places.
Yeah.
And you load one in that service, and one in that service, and two in that service.
Yeah, it goes super fast.
Well, it depends.
No, but you have. Because you have.
If the cache is empty, and you get one attribute there and two here and one there, there's three.
There's a warming up of the cache. So the first time you make queries, it will be a little bit slower, because you have to naturally go to the disk to get the data. So it will take longer time to get the first data, right? But if you get data about a user or 1,000 users, it's in memory. And then it's extremely fast to get the second time.
But in the traditional, you would have the same problem, right? You would fetch all the 10 things and all the 10 services. No?
Yeah.
Well,
and in a traditional service, you would have to go over the expensive network.
But yeah, that also.
To the server, and then get it to process it, and get it back into the application.
An entire entity also.
Yeah.
But that most of the time, that's not very expensive. It depends, of course, on the size of the entity. But if it's reasonable size, you would cache the whole entity, or you would get the object and pass that around, and you would have everything you need.
Yeah.
And it would be, and you could cache that, and it's useful for many use cases. In this case, you would have cache each attribute separately.
Yeah. But Atomic has 4 indexes. So it indexes by entity, 2 different ways, and by attribute and by value. So no matter which combination you do, it can create extremely fast queries, because it can use the 4 different indexes depending on which fact you're looking for. So for each fact, for each attribute, it might use different indexes. So it goes super fast to.
Yeah.
But of course, I don't have production experience yet with big systems, so I can't say for sure. But I really don't think from everything I've learned so far, also that I've seen in presentation, I really don't think it would be any issue.
I can just see from the system that we're building that we have, I'm not afraid of the size of the data. I'm afraid of the number of round trips to the database.
Yeah, but there's no round trips.
Well,
Mostly one, right?
it depends. If you have different entities all the time, it's not the same entities used all the time. Not in our system.
No, but
it's different.
any entity that is queried once is brought into the cache. So it's not that it's either the whole database or nothing. It's the peer caching mechanism.
Not all billions of entities.
What?
Not all billions of entities are cached.
No, I don't think so. It's and it also has an extremely fast way of I think it's called B trees. That the way they organize the data in the storage services, which is extremely fast to get to the data. So even if they have to go to disk, it goes really fast also.
And I guess there's nothing stopping you from also getting 10 fields at once if you want to.
Sure.
I mean, you could do a test case and see I'm actually querying billions and billions of stuff. You can never cache. Okay, I'll test and see what's faster. But I assume, I'm also from where you are, I'm so used to connecting to a MySQL or something. And thinking about it as a connection somewhere or with a network or even in the machine, but still, maybe you could almost see it as just accessing a variable in memory once the data is there. And once as long as the data, the amounts of data is not huge, I guess.
From what I've read in the forum about people who are like asked, I mean, they're talking about tens of millions of records that goes super fast in memory. It's maybe if you get over 100 million records that you might experience some lagging somewhere. I don't know. But I can say it probably also dependent on the specific structure of your data. I don't know, and the type of queries you're doing, I guess.
Can you like truncate after if the transaction history becomes really long? Can you like condense it, like take all the 10-year-old things and just condense it to the current state?
Yeah, there's a function in Datomic also for both you can define an attribute as having the option no history.
Mm-hmm.
So if you retract a fact, the old one is deleted.
Okay.
Because you might have some facts that you for sure know that you're never gonna need the history for those. So you might save some space for that. Thank you. And there's also a function called excision, where you can actually delete stuff. Because you might have legal obligations to do that. That you are not allowed by law to save certain parts of data, and then you can force to be deleted. But instead of just making it null, it says like there has been retracted values of this attribute at this time, but not what the value was. So you protect the value that was excised, but you still have information that it was, I think you say excised. Yeah. So it's more information than just nulling it out. So I think it's a cool feature. And they say from the Datomic, I just saw a presentation where he said like it was a very specific feature that people asked for, that we need to have excision, we need to be able to delete stuff. And then they implemented it, and then they realized that almost nobody used it once they started using the system. But it varies from domain to domain. Of course, some domains they require it. Yeah, it just asked you some 3 points. Like you get the data from the app process as we've been talking about, and you don't need to cast raw data from the database server to populate rigid domain classes, only to pull out the data again. That's what I was talking about. And you can get exactly the data you need, nothing more, and even optional data. And it's always typed data. And you can even make easy type-safe migrations, because if you want to change the name of an attribute, you can change it in your schema definition, and then you just transact that again, and then it's the new name that it's applied. And I need to implement one if you change the name, because then you want to have the history of that attribute value back in time. So even if it has a new value, you want to have it. But in your code, when you have this in your code, you might say like, oh shit, but then I have to change, if I change password to the full name, password, VORD, then you know that you can search for this in your code. Type safely, find it all the way, all the places you use it. If you compare that to text string queries, it's much more error prone to like find and replace in texts of queries. Right? Here you have the type system to help you to find anything that you want to change. So I think that's going to be powerful. And you're doing many terms directly. And you have a minimum of ceremony. You don't have like a long XML files defining the relation between the database and the database. And then you have a maximum runtime performance because all the queries has been prepared by the macros. They're ready to fire off exactly the query that you need. So the query over there is already prepared by the macro. So when you call get, boom, it can't be faster. And you have the whole time dimension, and it's fun to use. So that was it. So if you have more questions, maybe.
This when you change the schema and migrate,
Yeah.
can you encode that also as a transaction?
Yeah.
So that's what you do.
Well, the whole schema definition gets transacted.
Okay.
Well, it's just a transaction data that you send to the memory. And then it creates all the attributes with all the properties, cardinality, type, and all this. So it's basically just a list of key values. So then it creates the entity IDs automatically. So basically what you need to start using it, I have on GitHub, I'll show you the addresses here. Then there's also a demo project, which is the most basic, like just a person, name, age, example, where you can see how you define the schema and what you need to write in your build file. You import the molecule, you import atomic, and then you start, as you said, like defining other properties, and then you start making queries. So if you want to, I'll be happy to, if you have want to try it out with your domain, just give me a call and I could have a session with any of you if you want to try it out on something that you're working on yourself.
What are the pros and cons with event sourcing?
I don't really know. I mean, I've read a lot about it, and I was thinking of using it myself together with the DDD, and I read all the articles on the net and everything. But I think there's a lot of ceremony in setting it up. Of course, when it's up and running, it's super nice. But it's just that you don't have the time. You have to build the time model yourself in your domain, which you can do, and it will work fine. But here you have it at the core. So even the most simple updates you do in the system, everything is recorded with time added to it. So you don't have to worry about, oh shit, we should have had the time metadata for this information also, because now we need it, and we didn't have it half a year ago.
I guess you get the index for free.
You get index for free and log, an audit trail. So the things, the advantages that you get with event sourcing, which is like that you can replay stuff, you get also with the database as of or since, and then you can see all the transactions. You could even run them again. You can take the database at some point, and you can create a lot of events. The same, not events. You could create the same assertions and retractions to see why did it go wrong with that customer. They did something that messed up our database, and you can look at exactly what transaction that was, and redo them on this database as of this time, and then make all kinds of tests of why. Okay, it became like this because we forgot to consider the discount that changed just when they turned 40 or whatever. So you can get a lot of things, same things that you do with the commands and events, but it's at a core level, which I think is beautiful. And you can do it in a type-safe and easy way. So that's also why I implemented all the examples they did, because they're working in Clojure, and Clojure is great, but it's sometimes I envy some stuff they can do, but it's not typed. So you still have to type stuff. And here you get the types.
Maybe an event sourcing can get like different views, right, and have different interpreters.
Yeah.
I don't know if you can do that.
I think because you can do whatever case classes or whatever construction you want to do, and then compose any data that you need for this, and save it in any way you want to do it. So, for instance, I remember the events you showed in your presentation last time, like I can't remember, create person or
Something like that.
yes, I mean create, or it was different kinds of CRUD operations.
Basically,
course.
what we have is like create person, update name,
Yeah.
so on.
So instead of making a case class for each operation that you do, you just create a molecule, bang, straight on, and then it's done.
I guess those objects could contain like the metadata for the transaction. So you would have
Exactly.
like what user, what use
Yeah.
case, the case class
Exactly.
name is
Yeah.
maybe the use
Yeah.
case. So you still need to like capture that, and
Yes.
if you want to put it on a queue, you would
Yeah.
have to have some structure for that
Yes.
object on the queue.
Yes,
and that
you
would
have
be-
to model that, of course.
So it's not.
No, it's
you
not.
still
You still have
need
to,
those objects
Yeah.
and those fields.
but maybe you don't need a special case class for that operation, because molecule could do it straight away. It depends on the nature of the process. But to get the data, you could use a molecule, and to save the data, you could use a molecule. And then, of course, you would have some structure to do the mutations that you need or the processes you need. But I think it's just about trying it to see if it. Take one little example and see how would the same thing look if I did it with this. Yeah.
Great.
Yeah, thank you.